Okay, let's introduce mass into this whole story now. So far, things that we were working with, it may seem a little abstract to you because you still can't see those numbers. You can't see what do you mean by particles? We can't see those particles. If I was to ask you to work in a lab, I'm never going to ask you to isolate 6.02 times 10 to the power 23 particles of something. That's just not, you can't sit there and count that many particles. So what you can measure in a lab is actually mass. So it's important that we can equate mass with the numbers we are dealing with. And that's where this mass to mole conversions come in. And this is where our periodic table comes in handy time, because all those numbers that you're looking at in the periodic table and the atomic mass that you were looking at for everything isn't just some random mass. We're going to associate a unit to this mass now. So again, atomic mass that you see, atomic weight that you see in the periodic table, so far we're looking at that as just atomic mass unit. Lithium's atomic mass or atomic weight is 6.94 atomic mass units. Saying atomic mass units is just like saying, how far did you go? I went 5 distance units. You're not specifying anything. And so that number was really of not much use to you until now, except to count the number of neutrons. Now it becomes more useful, because now we're going to associate a unit to that. That 1.01, 6.94, all those numbers there have a unit, which is grams per mole. Grams per mole. Okay, so all of those atomic weight numbers you see, their unit from now on for you is grams per mole. Let's see what that means. What does it mean to be that many grams per mole? Hydrogen's atomic mass, atomic weight is 1.01 grams per mole. Which can be written as a fraction. Anything where you have a per value, you can write it as a fraction. 1.01 grams for every 1 mole. This is what that means. Okay? Hydrogen, for hydrogen, if you have 1.01 gram sample of hydrogen, then you have exactly 1 mole of hydrogen. Okay, and because we're dealing with just hydrogen by itself, that atomic mass is for hydrogen as an atom. This is hydrogen atoms. Okay, 1 mole of hydrogen atoms. You're not looking at the molecules, diatomic molecules. This is hydrogen atoms. What if then you have H2? If you have just H, this is a conversion factor you can use to go between moles and grams. What if you have H2? Well, H2 just has 2 hydrogens, 2 hydrogen atoms. So H2's mass, instead of calling it, this was the atomic mass, because we're dealing with an atom. Okay, this was the atomic mass. H2 is a molecule. So we're looking at molecular mass. Molecular mass of H2 would be 1.01 times 2, because you have 2 hydrogens there. Molecular mass calculations will always be done by looking at the atomic mass of the things involved. Okay, this one was very straightforward, 2.02 grams per mole. So what this tells us is that for H2 molecules, this would be the number you can use to go from grams to moles. What if it was something else more complicated? Al2, SO4, 3. Now, first of all, you can say what's in a name, but it is a formula unit. So you can't say molecular mass when you have an ionic compound. It is formula unit mass. Formula unit mass, and that would be an addition of all the atomic masses rather of everything involved. It has 2 aluminums, 3 sulfurs, that's S times 3, and 12 oxygens. Okay. So you go to your periodic table and find those 3 atoms. Find aluminum there, 26.98. Atomic mass of aluminum is 26.98. Since you have 2 of them, we'll multiply that by 2. That of sulfur is 32.06 times 3, and that of oxygen is 16. You add up, you multiply the numbers, and then you add up those numbers to get your answer. 342.14. The units for this answer will be in grams per mole. Grams per mole of whatever species you're looking at, Al2, SO4, 3.